Hi, this is Tom Reardon, math teacher from Ohio, with another SAT problem to solve. We will show you 3 different ways to solve this one. We encourage you to do this problem along with me and pause the video as necessary. The graphs of y equals 2x minus 2 and y equals x squared minus x minus 20 intersect at 2 points. What is the product of the x coordinates of those 2 points? So the first way we're going to do is we're going to graph these two. So in y1, I'll type in 2x minus 2. In y2, x squared minus x minus 20. And let's double check before we move on that we typed them in correctly. So I'll press graph. And it looks like there are 2 points of intersection. So we'll go ahead and find those 2 points. So second trace is the calculate menu. And number 5 is how we find intersections. So it says, is the first curve blue? Yes, enter. The second one red? Yes, enter. Now my guess is initially 0. I can type in any number. So if I type 0, I should probably get this point of intersection. So I'll just press enter. And there is one of my points of intersection, -3, -8. I can do that again to get the other point of intersection by pressing second trace down to number 5 for intersect. Blue, yep. Red, yes. But now if I guess -3, that's what I'll get. So I'd like to pick a number maybe closer to 4. So I'll just say I want to guess 4. Give me one that's closest to 4. And enter. And you can see that it's at +6, 10. So the product of those two is going to be -3 times 6, which is -18. Press pause as needed. And again, here are what I typed in and what my answers were. So for the second one, I'm going to use tables. So I have the same equations typed into y1 and y2. They're still there. And I have my table set to start at -5, delta table of 1, and these are both automatic. So I'm going to press second graph to view the tables. And I'd like to know when is y1 equal to y2. And I think you can see that at -3, that is happening. They're both -8. And arrowing down, still not equal, but there we go at +6. They definitely are the same. So this is where they're equal. So I'm solving by table. And so again, +6 times -3 is -18. So a second way, graphically by table, pause is needed. The third way is algebraically. I'll set those two y expressions equal to each other, and I'll subtract 2x from both sides and add 2 to both sides. So I get this quadratic equation that is factorable nicely. Setting each factor to 0, we're getting x equals +6 or x equals -3, and getting, again, the same product of the x values.